The final video for chapter 4 is going to be about relative motion. So first we need to define something called a frame of reference. So in general, right, so if you have, imagine you have some moving object, right, and you want to describe things like position and velocity and acceleration and whatnot. So in general, you can have different people observing this motion, and if they're moving with respect to each other, then they can be, the velocities and such that they measure could be different. So in general, motion can be observed by different frames of reference, or reference frames, and you can think of these as observers. So what we mean by a reference frame, or frame of reference, is a coordinate system that's attached to an observer or an object's perspective. It doesn't have to be a real person, of course. So, and the key point is that this reference frame is at rest with respect to the observer. Now, some notation here. So if I'm interested in a position, so let's say the x position, and I'm going to use x with a subscript AB, and by that I mean the position of object A relative to observer B, or relative to frame of reference B. So the first subscript is the object, the second subscript tells you the frame of reference. So similarly, so if you have a speed, V sub AB is the speed of object A relative to observer B. So in your textbook, they actually like to put parentheses. So they have an x sub A with parentheses around it and then another B. I just put the two subscripts together. Okay, so relative motion then. So if we are interested in positions, so and again, this works either in 1, 2, or 3 dimensions or even more. So if we have a position vector r, and I want the position vector r of object A relative to some frame of reference C, so what I can do is I can take the position vector of object A relative to some other frame of reference B, and then add in the position vector of that frame of reference B with respect to the other frame of reference C. So the way I like to think about it is you've got RAB plus RBC, and it's kind of like the B's cancel out. That's not really what's happening, but it's a good way to remember, though, to get the right order. So if we want to do velocities, well, we know velocity is just the time derivative of the position. So we need to take the time derivative of the quantity RAB plus RBC. So now we can distribute that derivative, and we take the time derivative of RAB plus the time derivative of RBC, and those time derivatives are just velocities. So the velocity of object A with respect to frame of reference C is going to be the velocity of object A with respect to frame of reference B plus the velocity of object B with respect to frame of reference C. And again, now, so we can then find accelerations. So if the velocity between these two reference frames is constant, so the way we set this up, that's this BC here. So that's telling us how the two frames of reference are moving with respect to each other. Now, if that velocity is constant, well then, remember, if we want acceleration, we just take the time derivative of the velocity. So we take the time derivative of VAB plus VBC. But if VBC is constant, the time derivative of 0. So if the velocity between these two reference frames is constant, then our accelerations are going to be constant. So this is the acceleration of A with respect to reference frame C is going to be equal to the velocity of A with respect to reference frame B. And this is actually a special case of something called an inertial reference frame, which is going to become important once we start to talk about Newton's laws. So just to get an actual concrete example here. So again, so we have a moving object. So we have a little boat, and the boat's going to go across a river. And the river is actually, there's some current in the river. So knowing this, right, so we can actually figure out, so if, let's say we know the velocity of the boat with respect to the water. Well, to get the and we want the velocity of the boat with respect to the shore. Well, to get the velocity of the boat with respect to the shore, we need to take the velocity of the boat with respect to the water plus the velocity of the water with respect to the shore. So VBW plus VWS, so the sum of those two vectors, is going to give us the velocity of the boat with respect to the shore. So remember the sort of the little mnemonic I use. If you look at the subscripts, so the little W subscripts, we want those to disappear. So we put those next to each other. So VBW plus VWS equals VBS.